Hey guys, how are you doing? तो this is the course for theoretical physics और इसका नाम मैंने रखा भी है फंडामेंटल फिजिक्स प्रिंसिपल. We are going to start with vector analysis, है ना. मैं आपको कुछ बातें बता देता हूँ. The medium of instruction is going to be largely English for graduate level और mix of Hindi and English both, है ना. So that at least जो भी बच्चे पूरे इंडिया में हैं, so that they should be able to avail this course, and apart from India, anybody can go through this course. This is the theoretical physics course and we are going to go with our own flavor. We will start with basic vectors, then calculus, maybe basic algebra, है ना. तो ये mathematical rigorous होने वाला है. This course is mathematically very rigorous. You have to have very good understanding, mathematics as a tool. You should be able to interpret, mathematical equations, mathematical graphs. And this is the pursuit of this course. It is going to be so long, and it depends upon your demand as well. So let's start with vectors, है ना. और अगर आपको कोई भी डाउट हो तो you can go to the comment section, you can comment there. But by and large, I have talked, what is the basic idea behind this course. Okay, what are the vectors? Let's begin with vectors. देखो vectors क्या होता है मैं आपको बता देता हूँ. जब भी हम physics पढ़ते हैं, we always start with vectors because without them we cannot, huge, certain quantities. For example, vector is like this, अगर मैं geometrical meaning की बात करूं, and most importantly, let me show you the book I am going to use for this is, this is vector analysis by Som series, है ना. This is the standard book I am going to use. I am going to use lots of examples, lots of problems from this book. This is the book Electrodynamics by Griffith, and then we will go for the J.D. Jackson, which is very difficult book although. And for mechanics, this is again used. This is the introductory mechanics by Clapton and Kolenko, and thereafter we will go for Lagrangian and Hamiltonian physics, in which I am going to use Goldstein, the book. Okay, but for that matter, this is the beginning. We will go with this book. All right. Okay, so let's back to the vectors. Vectors के पास दो चीजें होती हैं. Let me tell you, there are two things. Vectors has magnitude, so a quantity which has magnitude and its direction. Okay, but if you were to show the magnitude, how you are going to do that, let me tell you. Okay, दो magnitude जो है basically आप इसको कैसे डिनोट करेंगे मैं आपको बता देता हूं. आप इसको डिनोट करेंगे इसकी लेंथ से. तो लेंथ इज बेसिकली अबाउट मैग्नीट्यूड. ओके, दिस इज द लेंथ. ओके, तो टिपिकली ज्योमेट्रिकली अगर आपको वेक्टर शो करना है तो मैग्नीट्यूड, एंड यू कैन ऑलवेज पैरामीटराइज इट लाइक 1 सेंटीमीटर किसके बराबर होता है. एंड दिस इज द हेड. हेड क्या शो करेगा? डायरेक्शन शो करेगा, है ना. तो हेड क्या करेगा? डायरेक्शन शो करेगा. तो एसेंशियली जो सिंबल है, व्हाट इज द सिंबल गोइंग टू बी फॉर वेक्टर्स? The symbol is like this. If this is a quantity A, which is a vector quantity, then I can tell you it has two things, A and A cap, A hat. Sometimes you can call it A hat. What is this? This quantity is called magnitude. This particular thing is called magnitude, and this is the direction part. Immediately, what you can do, you can easily identify, or you can easily, calculate the direction A hat. Most important, this is direction A. And this is okay. So by definition, A cap कितना हो जाएगा? A cap is going to be equal to vector A over its magnitude. Okay, this is the most important thing. Okay, I am not going to use any particular coordinate system right now, but for that matter, you should understand this. What are the example of these quantities? For example, first quantity is displacement. Okay, and if something is not vector, then it is a scalar quantity. And let me tell you, scalars are just numbers. Okay, they don't have any direction. So scalars, okay, scalars are basically numbers. Okay, अभी बहुत basic से हम शुरू करें. Scalars are numbers. They have only magnitude. They have only magnitude. Okay, they don't have any direction for that matter. And most importantly, if they have magnitude, तो एक चीज ध्यान रखना. We should always start with some examples. Example is like mass. So you don't need to specify for that matter the direction of mass. Okay, because there is no meaning of the direction of mass. Okay, for example, if you were to talk about length, for example, if you were to talk about distance, but the major important scalars, for example, in physics are mass, charge, time. Okay, again, you can also talk about work and energy. They are, work is equivalent to energy, energy is equivalent to work. You don't need to show any direction for that. Right? Okay, there are certain things, which requires component. I'm not going to talk about tensor right away. We are going to do tensor analysis extensively in this course, right? but we are beginning with the very basic. So I am going to talk about, for example, pressure. Pressure is a scalar quantity for that matter. Okay, pressure, because it talks about only the component of the force. Okay, perpendicular component of the force divided by the area. Okay, most important. So when you talk about, when you talk about vectors, so vectors के जो examples होंगे, typical examples of vector, for example displacement vector. Okay, I was writing here. Okay, so example is displacement vector. How you are going to talk about displacement vector? X is a displacement vector. So by definition, its magnitude is going to be distance, x, and x cap is going to be its direction. For that matter, अगर ijk के बारे में, if you guys are comfortable with ijk, base vectors, I am going to use them. X is going to be I cap. Okay. Similarly, if I have this vector velocity, this velocity vector is going to be speed times some v cap. Again, you can use any coordinate, but you should be, to get into theoretical physics, you have to be good at any symbol for that matter, not necessarily ijk coordinates, it can be in r cap direction, theta cap direction for that matter. Okay, but v cap is one of the standard way to show this, it can be anything. This is vector v over. Okay, you can talk about electric field, we are going to talk about fields extensively. So electric field is going to be some magnitude attached to this field and e cap direction. It can be anything, e cap direction can be anything and anything. Okay, now let me ask you this question. How about current? Okay, current कैसी quantity है? How about electric current? Is it electric current कैसी quantity? Is it a vector quantity or a scalar quantity? Obviously, because the direction of, for example, I have the conductor, like where there is some potential drop हो रहा हो मान लो, तो by definition current is in the direction of the positive charge. So if electron is negative charge, if electron is moving towards leftwards, the current is going to be moving towards the right side. Okay, that is the basic idea. The answer is it has direction, current has direction both. Suppose I have this kind of circuit like this. Okay, parallel circuit, typical example of the parallel circuit अगर आपको ध्यान हो, ये गया ऐसे 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 ऐसे, है ना, like this. So you have, suppose you have this R1, R2, R3 resistors. Current I is moving like this. I1 goes to this branch. I2 goes here. I3 goes here, and again they end up becoming I. है ना? They added up to I itself. Okay. So current, total current I, junction KCL, है ना? Kirchhoff current law. तो आपको Kirchhoff current law याद होगा. I equals to I2 plus I3. There is no, charge is not piling up, charge is conserved here. Total current is equal to individual current, sum of the individual current. Okay, and that makes it a scalar quantity. It is a scalar quantity, current is a scalar quantity, and you must ask, it has direction, it has magnitude, but then why do you call it a scalar quantity? Because it is obeying ordinary algebra. That is again the most important thing about vectors. Vectors do not obey ordinary algebra. So vector have their own algebra, and therefore the third thing which we must remind of ourselves, not only direction and magnitude, but they obey their own algebra, vector algebra. They have their own algebra, they have their own rules, vector algebra. That is the most important thing. Okay, and this is again the book, you can go through this book, you will find everything here, written like this, and let me check, if I have not seen it over. Okay, anyways, so I am going to talk about vector algebra. So let's talk about vectors now. Again, देखो vectors के बारे में सबसे important जो वो है space में basically, जो ये vectors है, for example, let me take this vector, है ना, suppose I take this vector, मैंने इसको क्या कर दिया, parallel again, if you can look at this, all these vectors are same, है ना, क्या फर्क पड़ रहा है इसका बताओ, कुछ भी नहीं फर्क पड़ रहा. Are these vector different? No, they all are same vector. Why they all are same vector? Can you, if I were to ask you, if this is vector A, this is vector A, all of these are vector A, है ना, why are all these vectors same? क्योंकि मैंने इनको स्पेस में ट्रांसपोर्ट किया, पैरेलली ट्रांसपोर्ट किया. पैरेलल ट्रांसपोर्ट हैज नो इफेक्ट ऑन वेक्टर्स. Parallel transport has no effect. This is called a parallel transport. Why parallel transport works? Because of definition, by definition of the vectors. What is the by definition of the vectors? Simple. By iski jo length hai, it is not changing. I am asking you few things. What about magnitude? Magnitude is the length. Did I change the length? No, I didn't. इसका मतलब अगर लेंथ सेम है तो मैग्नीट्यूड सेम होने वाला है. हाउ अबाउट डायरेक्शन? Direction is also going to be the same. Did I change the direction? No. Suppose if you were to for example, if you were to attach a particular frame of reference to this particular direction, let's say I cap, it is all these vectors are parallel to that I cap direction. Let's say कोई भी डायरेक्शन अगर आप चूज करोगे, और इवन मान लो यहां से कोई थीटा है ना, सपोज करो इफ आई हैव दिस कोऑर्डिनेट सिस्टम सिटिंग हियर, ओके, एंड इफ अगर मैं इस वेक्टर को यहां से पैरेलली उठा के यहां से इसका पैरेलल यहां खींच लूं, एंड इफ इट इज इन दिस पर्टिकुलर, अगर मैंने आपका कौन सा कोऑर्डिनेट सिस्टम लिया है, दिस इज द वेक्टर ए, तो दिस द कंपोनेंट अलोंग द एक्स एक्सिस इज a cos theta for all these vectors. Each of these vectors are along the same. So this is the most important. And with that idea, you can easily find out negative of a vector. So how do you find a negative of a vector? So this is, and why the hell we need negative vector? क्यों चाहिए हमें negative vector? Mathematical requirement है. What is negative vector? So if you want to talk about vectors, negative vectors, suppose again this is vector A. Now what you are going to do? Just rotate 180 degree. Okay, ekdam parallel, just 180 degree rotation. So if this is vector A, if this is vector A, this is going to be vector minus A. What is the necessity of this vector? When you add two vectors, yaad rakhna, closure property. What is closure property? Closure property suggests if you add any two vector, you are going to get a vector quantity only. Okay, so it is kind of you have a set of vectors. तो अगर मैंने उस सेट में से किन्हीं दो वेक्टर्स को ऐड किया तो आई एम गोइंग टू गेट द रिजल्टेंट वेक्टर इन द सेम सेट. दैट इज व्हाट इज द क्लोजर प्रॉपर्टी मीन. सपोज वी आर गोइंग टू टॉक अबाउट सेक्टर ऑफ n वेक्टर्स, फॉर एग्जांपल a1, a2, a3, some indices है ना ai. So if I were to add some ai, aj, and I am going to get some ak, these ijk vectors are going to be the part of this vector, है ना. n वेक्टर्स का जो ये सेट है इसी में मिल जाएगा, कोई भी वेक्टर हो सकता है ना, और फॉर दैट मैटर एनी वेक्टर्स फॉर दैट मैटर, i j k 1 2 3 so on, कुछ भी हो सकता है. ऑल ऑफ these vectors are the part of this set. देखो अगर आपकी जो इसकी मैथमेटिकल नेसेसिटी क्या है, लेट मी टेल यू द मैथमेटिकल नेसेसिटी. सपोज यू हैव दिस वेक्टर a and you are going to vector b and you are going to have vector c. okay, नेक्स्ट अगर आपके पास किन्हीं भी दो वेक्टर्स को ऐड करके क्या आ रहा है, वेक्टर सी आ रहा है, तो मोस्ट इंपोर्टेंटली व्हाई डू आई नीड इट? सपोज बाय डेफिनेशन दिस इज बी वेक्टर, व्हाट यू आर गोइंग टू ऐड, a प्लस ऑफ माइनस a, you are going to get zero vector. This is called null vector. Most important aspect, this is the concept of null vector. okay, तो this is the concept of null vector. अगर आप देखेंगे तो जो null vector है, null vector या zero vector, null vector or zero vector, no direction. okay, direction is not specified, not specified. If anybody asks you how about the direction of null vector, not specified, what is the magnitude of this zero vector? तो zero vector का magnitude क्या होगा? Zero. This is the magnitude of the zero vector. That is the most important aspect. I guess you can understand. I can keep my okay, अपनी फोटो इमेज एक बार हटा देता हूं ताकि so that you could watch it. okay, you could see it. I think all right. okay, now if you have done this, so we can move ahead now. all right, okay, now let's talk about addition of two vectors. How do we add two vectors? So for addition we have something called triangle law of vector addition. What we call triangle law of vector addition. Just a minute, let me, okay, This is called triangle law of vector addition. Okay. Okay. So what is triangle law? How do we add triangle law? देखो ट्रायंगल लॉ का सीधा सीधा मतलब ये है, एंड ऑल ऑफ यू मस्ट बी, बिकॉज दिस इज अगेन फॉर द फिजिक्स गाइज, दिस कोर्स इज अबाउट फॉर फिजिक्स गाइज, है ना, ट्रायंगल लॉ ऑफ एडिशन. ओके, ट्रायंगल लॉ ऑफ एडिशन. लेट मी यूज माय कंप्यूटर फॉर दिस पर्पस. ओके, ट्रायंगल लॉ ऑफ एडिशन. सीधा सीधा जो कॉन्सेप्ट है बहुत सिंपल है. व्हेन यू हैव टू वेक्टर्स एंड यू वांट टू ऐड देम, now you got to understand, you know what you need to understand. Try to understand this. Okay, this is vector A, and then you have this vector, let's say, you know, vector B. Okay, तो आपके पास दो वेक्टर्स हैं. वैसे तो how should you do that? Basically, whenever you want to add these two vectors, how you are going to add these two vectors? You have vector A, इसका ये head है, and how do we add them? Head to tail. You know, this is going to be vector B. तो आपका जो ये वेक्टर का एडिशन आएगा, what you are going to get? You are going to get, this is the resultant vector by definition. This R is the resultant vector, and this is called triangle law. This is called triangle law of addition. And in this particular diagram, you could understand, you know, whenever you have two vectors like this, vector A, and let's say you have another vector attached to this, you know, with some angle theta. Suppose this is angle theta, right? And this is vector A, this is vector B. Extensively we are going to use this vector. You have to have, I can easily parallel transport it, and once I can parallel transport it, it is very easy for me to find the resultant, and this is going to be the resultant vector. Okay, this is going to be the resultant vector. And again, so if you were to, for example, bring this here, you get a parallelogram. This is called parallelogram law. Okay, parallelogram law. Okay, and we are not going to I am assuming that you have basic building, basic, you know, understanding of, this is called parallelogram law. Okay, let me use this computer to write this. Again, it is not able to write. Okay, it is killing our precious time, but anyways, okay, I think now it can write. Okay, this is the parallelogram law. So suppose this is vector B, this is going to be, अगर ये vector B है तो this is also vector B. If this is vector A, this is also vector A. And sometimes we call it the parallelogram law. Okay, the same thing, you know, identical things. This is, let's say, angle alpha. So this is at angle alpha. Okay, and अगर आप इसको देखेंगे, what are you going to get? Suppose you are going to get, it is at theta. Once I want to calculate, for example, you know, the magnitudes. How do I get the magnitude? You know, you need to draw a perpendicular onto this base, और यहां से जैसे आपने perpendicular क्या कर दिया, डाल दिया, तो यहां पर जो आपके पास आएगा, what you are going to get basically, or otherwise you can do here also like this. Okay, so this is going to be, this length is going to be b cos v sin theta, है ना. This is the length, this length is b sin theta, this length is b cos theta. And whenever you want to apply, you know, which theorem, Pythagoras theorem, तो जैसे ही आप इस पर क्या करोगे, Pythagoras theorem लगाओगे, what you are going to get, Pythagoras theorem. How are you going to use Pythagoras theorem? The length है ना, for magnitude, है ना. Magnitude simply means length. Again, just don't forget about length. How you are going to get the length? You are going to get this r vector, length of this r vector, or otherwise from here itself. Okay, you can use b sin theta, and this length is b cosine theta, है ना, b cos theta. So you are going to get r squared equal to a plus b cos theta whole squared plus b sin theta whole square. Okay, and now what you have to do, just, you know, rearrange the terms, and you are going to get a square plus 2ab cos theta from here you get b square cos square theta. I am taking common. From here I am taking sin square theta common, which will be equal to 1. So essentially, finally, what do you get? So this resultant, this length of this resultant vector, because it has to be vector from the which property? Closure property. You are going to get a squared plus b squared plus 2ab cos theta. Interestingly, if you look at, and again for direction purpose, this is the magnitude. This is the magnitude. For direction, what you are going to get, है ना? अगर हम direction के बारे में बात करें, तो for direction you have to simply apply this tan alpha, and you get, okay, all right. Just let me check it, okay? So you are going to get tan alpha is going to be this tan alpha is going to be b sin theta divided plus a plus b cos theta. And interestingly, what you can see, you can have degenerate triangle when theta equal to 0. Okay, most important. This is the most important. When theta equal to 0, you have a degenerate triangle. What is degenerate triangle? This is going to be most important, degenerate triangle simply mean you have two lines, vector A, vector B, and you are going to have r equals to vector A. You are going to have a line segment essentially. What you are going to have? Line segment, and r is going to be a plus b, because a plus b whole is squared, right? R equal to a plus b whole is squared. That is the most important aspect about triangle of vector addition. All right. So quickly, let me tell you what I am going to talk now, some properties, and then I am going to ask you to solve some questions today. All right. We have discussed about proper vector, null vectors, है ना? All right. Now vector algebra, laws of vector algebra, and then we are going for the some, laws of vector algebra. This is most important. Okay, this is going to be the most important, and extensively we are going to solve problems. This course is about problems basically, mathematical rigor. So theoretical physics is about, mathematical, right? So what we are going to do, let me tell you what are the, laws I am going to use. For example, closure property. First property is the closure property. Okay, so first property is the closure property. We are going to talk about, for example, just a minute. We are going to talk about, extensively about group theory, right? And where we are going to use this, when you have this vector a plus b equal to r vector, r has to be vector. R is also a vector quantity. R is also a vector quantity if a and b are vectors. Okay. So for any two vectors, the sum is always a vector quantity. Okay. And when you say this, what does that mean? It simply means it has also magnitude, it has direction, it also obeys all these laws, whenever, right? तो इसका मतलब ये भी हो गया कि अगर मैं कभी भी a plus b plus c करूं, तो I am going to get this d vector. It simply means r plus c is going to be d vector. Okay, that is the idea, but I am going to use this on. Just say, what is the second property? Most important, commutative. Commutative, under addition, two vectors are commutative. Commutative simply means if you change the order, it is not going to make any difference, and you can look at it, through the diagram. So a plus b is same as b plus a. This is going to be the same. Okay, and both of these are the vector quantities. Most importantly, third one is associativity. Associativity. What is associativity? Associativity simply means you have two vectors a plus b. If you want to add first a plus b, or otherwise what you can do, you can keep a and you can add first b plus c, then add a. कोई फर्क नहीं पड़ने वाला. It is associative for addition. Okay. Scalar, most important, scalar multiplication. Vector multiplied by a scalar, ये सबसे important है. Vector multiplied by scalar. Okay, suppose you have some scalar lambda. अब ये कुछ भी हो सकता है, lambda is a scalar. What you can have, lambda a is going to be for lambda greater than equal to 0. अगर ये lambda positive है, it is going to change the magnitude. change the magnitude. Okay, suppose lambda equal to 2, so you are going to have a vector as long as twice of the length of the initial vector है ना. Similarly आपके पास lambda equal to 0 भी हो सकता है, it is going to give you 0 है ना. For lambda less than equal to 0, lambda a का क्या होगा, magnitude and direction both are changed. Magnitude and direction both are changed. Both are changed. That is the again aspect. Okay, it is, suppose you have two है ना, suppose you have two scalars m n a, तो आप क्या कर सकते हैं इनको, टू स्केलर m n वेक्टर है where m n n are scalars. Okay, similarly you can have m plus n, if they are going with vector a, they go you know m के साथ a जाएगा और n के साथ भी a जाएगा, these okay. Example, for example 2 plus 3 and you have vector a, what do you get, twice of vector a plus thrice of vector a, it can be minus as well. Okay, and finally suppose you have this m going with a plus b. Okay, so it can go separately with ma plus mb. This is called distributive law. Okay, these are the distributive laws. All right, this is the vector analysis, the basic part of the vector analysis. Okay, now what I'm going to do is I'm going to show you some questions now. So okay, just look at this question. Okay, this is the question for you first. This is the first question. What you are going to do, given vectors a b c, construct a minus b plus 2c. Okay, अब ध्यान से देखना, मैं आपको यहां से इसको कॉपी करता हूं. This is vector a. Okay, I am taking, this is vector a. Okay, first part, what I am doing, this is first part I am doing. Okay, minus b is going to be like this. Okay, so this is b, this is going to be minus b, a minus b. Okay, let me check if I can bring them. I think you can see it. This is vector a, this is vector minus b, and what you have to do, twice the length of 2c. This is the length of 2c. Okay, this is 2c. Okay, this is 2c. First what you are going to do है ना, अगर मैं इन दो वेक्टर्स को ऐड करूं तो मेरे पास क्या आ जाएगा, a minus b. This is going to be a vector minus b vector, and finally what do you want, this is what you want, 2c. This is what you want. Okay, so this vector is 2c. All right, so finally what you want to say, so this is the answer. Okay, minus b, so that this was b, this is minus b, this is twice of c, so this is the construct, and finally if you want to get, this is the final vector a minus b plus 2c. So this is what you can do. Okay, you can parallelly transport this vector. Okay, if you want only the answer like this, what I can do, if you want to just look at, this is b, this is c, it will look like this. So this was vector a, this was minus b, this is vector 2c. This is the answer. Simply this is the answer. Okay, and if you want to check the final answer, this is going to be a of minus b plus 2c. Okay, now this is homework for you. The b part is homework for you. This is homework. Just go through this part. Okay, I hope this is clear to you. Okay, तो you can, है ना, तो ये आप इस तरह से क्या कर सकते हो, you can easily solve it. Okay, now I am showing you another question, most important. Just a minute. ठीक है, इसको सॉल्व करके बताओ. गिवन टू नॉन कोलिनियर है ना, व्हाट इज नॉन कोलिनियरिटी बाय द वे, मोस्ट इंपोर्टेंट, टू वेक्टर्स आर नॉन कोलिनियर। कब होंगे दो वेक्टर्स नॉन कोलिनियर? तो आपके लिए क्या है, टू नॉन कोलिनियर वेक्टर्स ए एंड बी, फाइंड एन एक्सप्रेशन फॉर एनी वेक्टर आर लाइंग इन दिस प्लेन, यू नो कोलिनियर। यू नो कोलिनियर का मतलब होता है, let me tell you what is collinearity mean. Okay, it is too thick. Collinear, collinear का मतलब है two vectors parallel to a line. Suppose I have this line, okay, this is any particular line or any axis for that matter. ये vector सारे के सारे collinear vectors, all of these are collinear vectors, है ना? और what you can do, okay, you can make with other colors, है ना? This is different vector, this is different vector, all of these are collinear vectors, these are collinear vectors. Okay, let's say this is vector A, this is vector B, this is vector C. All of these vectors A comma B comma C are parallel to a given line, parallel to a given axis or line, है ना? Given line, they are collinear vectors. So A is not parallel to B, है ना? तो ये A कब होगा? तो what is non-collinearity mean? Non-collinear vectors, two vectors are going to be non-collinear when if A vector is not parallel to B vector, parallel to B vector. Okay, so how is that possible? Suppose I have this vector A, I have this vector B, you know, they are not parallel, simply mean if you were to like this, इसको घुमा दो ऐसे घुमा दो, two vectors, they are not parallel. This is vector A, this is vector B, they are non-collinear vectors. Okay, if their initial point coincide, they are going to determine a, so suppose, ध्यान से देखना, suppose if we coincide their initial point, what you are going to get? कॉमन सेंस से सोच के बताओ, तो ये मेरे पास वेक्टर ए है, इसको यहां पकड़ा मैंने, एंड व्हाट आई एम गोइंग टू डू, आई हैव दिस वेक्टर बी, नाउ दिस इज वेक्टर ए, दिस इज वेक्टर बी. ओके, नाउ व्हाट आई कैन डू, मोस्ट इंपोर्टेंटली, सपोज इफ आई हैव, अब मैं इसका मैग्नीट्यूड बता सकता हूं किसी भी नंबर से अगर, है ना? कैन आई डू दैट? सपोज दिस पॉइंट, लेट्स से alpha beta gamma, you can say anything, alpha times or beta times b, beta times b, beta is a scalar, beta greater than 0, scalar quantity. Similarly, what I can do, I can also increase this length to any point, whatever, wherever I want to go. This length can be alpha times vector a. Okay, this length. Now if I have another vector, let's say, which the question is saying, find an expression for any vector r lying on in the plane determined by a and b. So a and b is now determining what they are going to do. Let's say I am going like this, this is vector r. Okay, तो a और b क्या कर रहे हैं, a और b को मिलाने पर they will determine a plane, they are going to determine a plane. So suppose I have this vector r, है ना, I have this vector r. तो ये जो r वेक्टर है मेरा, दिस r वेक्टर, इट इज बेसिकली, अगर मैं इस r वेक्टर को लिखूं तो कंपोनेंट वाइज व्हाट आई कैन से, दिस इज दिस r वेक्टर, इट कैन बी रिटन एज कंपोनेंट वाइज, दिस कैन बी रिटन एज अल्फा टाइम्स a प्लस बेटा टाइम्स b, अल्फा टाइम्स a, बीटा टाइम्स b, दैट इज द मोस्ट इंपोर्टेंट एस्पेक्ट. Okay, so what I can do, this r vector can be, this can alpha can be cos theta, है ना? जैसे फॉर एग्जांपल अगर मैं इसका यहाँ पर प्रोजेक्शन डालूं, है ना, if I were to drop projection for example, okay, like this, okay, I can drop projection here also. तो अगर ये थीटा है फॉर एग्जांपल, तो आप इसको क्या कर सकते हो, जैसे कोऑर्डिनेट सिस्टम में हम यूज करते हैं, फॉर एग्जांपल व्हाट वी यूज, जैसे मैं आपको बता दूं, तो आपके पास ये कोऑर्डिनेट्स हैं, suppose you have this coordinate system. X and y axis. X axis, y axis. What do you get? Like this vector. So this vector A can be written as vector A equal to AX, some number in I cap direction, AY in J cap direction. Okay. So alpha and beta, they are basically, they are behaving like directions. है ना? So A vector, this A vector, sorry, these are behaving like direction. So R vector can be written as alpha A plus beta B. And if this is so, they are non-collinear vectors. If it can be written as, then A and B are non-collinear vector. Okay, that's the basic idea. What I'm going to give you homework, Anna. So if you have understood it, let me just remove my image for that matter. Okay, so these vectors, these are component of R along B vector and A vector. Okay, that is the most important for you. Now, all right. So what you are going to do? This is homework problem for you. Given 3, this is again homework problem. Go through these kind of problems. You will understand all these things once you develop habit of solving questions your own. Okay, all right. For example, prove that A and B are non-collinear, then XA plus YB equal to 0 implies X equal to A, Y equal to B. Okay, so non-collinear vectors by definition, this is the non-collinear. And the non-collinear, if A and B are non-collinear, then XA plus YB will 0 implies. Okay, so X non-collinear vectors. So let me show you. Suppose this R vector is defined as X time A plus Y times B vector. Okay, in our particular case, if XA plus YB equal to 0 vector, it simply mean XA plus this YB equal to some 0 times A plus 0 times B, or it simply mean X equal to 0, Y equal to 0. But let's say conversely, if we say, if conversely है ना, अगर इसको प्रूव करना है, what we can do conversely, what we can say conversely, if X equal to 0, so what does that mean? X equal to 0 means XA plus YB equal to 0, है ना? XA plus YB equal to 0. What does that mean? So XA, let's say XA does not equal to 0 लेते हैं, ठीक है? तो XA बराबर minus of YB and A vector will be equal to negative, है ना, minus Y by X into B. Okay, A vector is going to be minus Y by X into B. What does that mean? It simply means this is a number, Y by X is a number. So A is parallel to vector B. If it is negative, then it is anti-parallel, which is not the case. And if A and B are parallel, then they are linear, collinear. Similarly, if let's say Y does not equal to 0, if Y does not equal to 0, YB is going to be equal to minus X by A. So B is going to be minus X by Y A. Again, B vector is parallel to A. If V vector is parallel to A, they are collinear. So it is, the hypothesis is wrong. Okay, the structure hypothesis is wrong. So XA plus YB equal to 0 simply implies that X equal to Y equal to 0. That is the most important aspect. All right. Okay. Now, if you look at this question again quickly, if x1 a vector, y1 b vector, these are the bold letters, they represent vectors, x2 a vector, y2 b vector, ab are non-collinear vectors, then x1 barabar x2, y1 barabar. Okay, so it can be rewritten as x1 a y1 b vector, x2 a vector plus y2 b vectors. What I can say now, what you can say, x1 minus x2 a vector plus y1 minus y2 v vector equal to 0 vector. And again, from previous question, previous theorem, we know xa, not xa necessarily, any for that matter, alpha a plus beta v barabar 0 vector implies that alpha equal to beta equal to 0. And once you apply this concept in this particular idea, what you are going to get, x1 minus x2 barabar 0, y1 minus y2 barabar 0. It simply means, it simply translate to x1 equals to x2, y1 equals to y2. That's what we have to prove. Okay, all right. Okay, this is homework problem for you. Again, you have to solve some of these problems your own, है ना, आपको solve करना पड़ेगा. If you don't solve the problems, you don't understand. Okay, this is homework problem. This is homework problem. Now, what I am going to show you, and with that we are going to end this is called a plus b vector is less than equal to triangle inequality. I am going to prove this triangle inequality for you. Okay, this is called triangle inequality. Okay, we can prove it by different methods, but what I am going to do now, I am going to use the basic triangle methods. Okay, तो सबसे पहले triangle मैं आपको बता देता हूँ. Suppose I have this triangle. Definition of a triangle. Okay, definition of triangle. So suppose I have this vector, let's say these are the, है ना, मान लो आपके पास क्या है, ये है साइड A, इसके सामने की साइड B, this is the techniques C, है ना, these are the sides. Okay, these are the side of the triangles. Okay, this is C. Okay, this is A by definition, this is C, this is by definition B के सामने भी ABC. What is the property of triangle? Let's go to the property. What is the property of triangle? Simple property of triangle is sum of any two side is always greater than the third side. Okay, that is the property. यानी कि for that matter, if you have A plus B, it is always greater than C. Or simply, the length of B plus C, it is greater than A. B plus C is always A. C plus A is always going to be greater than B. Okay, ठीक है. Limiting case, if I were to, when triangle, when sides are replaced by vectors, okay, let's say I have this vector. So what I am going to get, suppose this vector A vector plus B vector, है ना, इसका जो magnitude है, length है, it should be greater than C vector. Or simply A vector plus V vector, this length of this vector, it should be greater than the C vector. That is the idea. Okay, all right. So if I were to talk about what is this C vector now, you can ask you, what is this? What is this? What is C vector? So if you remember again, let's take this triangle here. अगर इस triangle को यहाँ पर लेके देखें, what you are going to see, this is vector A, this is vector B. Let's say this is vector A, this is vector B. Just remember, this is going to be C vector, which is going to be A vector plus B vector. Okay, A vector plus B vector. So length of, so what I can say, two different lengths. So what you can say basically, okay, you can write it like this. What you can write down, length of A, length of vector B is greater than equal to length of C. Otherwise, or length of this side A, length of this side B, it is greater than the vector C. Okay, but what is vector C? Vector C is basically this length. Vector C is basically the sum of vector A plus B. That's the basic idea. Okay. Now, in case of limiting case, limiting case, most important, you should understand this. In limiting case, it is called degenerate triangle. It is called degenerate triangle. Degenerate triangle simply mean in vectors what we can have equality sign. A plus B can be equal to C. कब? जब ये क्या बन जाएगा? जब ये vertices become collinear, है ना? All vertices become collinear, है ना? Collinear. For example, suppose I have this vector A. Okay, है ना? For example, I have this vector A. I have this vector B, degenerate triangle. This is going to be vector R or C vector. So this is vector A, this is vector B, this is vector C, which is equal to A plus B. And in this particular case, degenerate case, length of A plus length of B equals to length of A plus B. Okay. And अगर आप क्या करोगे, this is, let's say this is equation 1, this is equation number 2. If you were to add these equation 1 and 2, what you can get from these two both equations, you get, finally what do you get? Length of side A, length of side B is greater than equal to length of A plus B. Or if you want to write it like this, A plus B vector, it is always less than equal to A and B. This is the most important identity. All right. So with this, I am going to wind up, this video today here only. आपको क्या करना है? We are not going to keep video more than 50 minutes length. That is the standard. All right. So A minus B, prove this one and also prove this one. I can prove this one. So this can be, it can be proven for any number of vectors. This can be proven for, okay. तो ये तो आपके लिए क्या हो गया? This is कहाँ गया? This is going to be homework. One problem, essentially you have to solve your own. Okay. And now the last one, A plus B plus C, for example, you should be able to do it. You should be able to do it. Okay. So I think this is it for today class. Okay. And how do you do that? Quickly, let me tell you. If you want, पहले A plus B को ले लो, associativity. So if you remember associativity, what is associativity? You have these two vectors A plus B, you can first add them and then you can add these C vectors. Okay, for A plus B, for that matter, if I were to talk about, let's call this is, let's say A, B, C, D, let's say this X vector, है ना? Let's define X vector, which is A plus B. So now I have this vector X plus C. So what you are going to do, we know for any X plus C, it is always less than equal to vector X plus vector C. Okay. And for A plus B vector, it is always less than equal to vector A plus vector B. From these two equation, what you are going to get, अगर आप देखेंगे इसको, call this equation 1, call this equation 2. Now X is what? This is X actually. This is X. Okay. So what you are going to get? You are going to see A plus V vector plus some C vector. It is essentially X vector is less than equal to vector A. Okay. Length of vector A, length of vector B plus length of vector C, and it is going to be less than equal to. In journal, what you can do, in journal, what you can say, most importantly, in journal, what you can do, summation of I cap going from 1 to n ai vector. Okay, you can add them. What do you get? It is always less than, just remember, sum is now outside 1 to n and vector is individual vectors ai. Okay, this is a general inequality. So thank you so very much. Now it is around 50 minutes. See you guys until next time, and I hope this video was useful for you. Thank you. See you until next time, and please do homework.